So far, we've learned a little bit about subtractive synthesis. You'll remember last week we used a sawtooth waveform generator and a resonant low-pass filter to create a subtractive synthesis patch. And this patch shows a new approach to subtractive synthesis. Instead of using a complex pitched waveform, in this patch we use a noise source and apply a bandpass filter. Once again, we have our two-dimensional control interface using the picked slider, but in this case the horizontal motion changes pitch, while the vertical motion changes what we might call pitchedness, or using the terminology from Pierre Schaeffer, mass. Here's a little bit of what it sounds like. Now, instead of having a volume as one of the axes, we have an envelope generator. And in an earlier video, I introduced you to the mousestate object, an object that captures the current condition of the mouse and the mouse button. And so we've made a little patch here that sends a poll message when the patch is opened to start polling the state of the mouse. The first outlet of the mousestate object reports the mouse button, 1 for down and 0 for up. A new object that we haven't seen before, the select object. The select object produces a bang when the input matches one of the arguments. So here you can see that we get a bang if the input matches 1, and here we get a bang if the input matches 0, and the final outlet gives us a bang for any other input. So when the input matches 1, when the mouse button is down, we've got a button object here just to display that, it triggers the function object, which sends its message to the line object, which is then used to multiply the amplitude of the signal of volume control, and then it goes out to the output. You'll notice here that I've got a multiply object here that provides multiplies the amplitude by 0.3, a third, which is about 10 dB reduction in level. Gives us some headroom for the resonance when we get up to the top. When I take my finger off the mouse button, we get a bang out of this outlet, which triggers this message, and the function object understands the next message to trigger from a sustain point. So we create a sustain point in the function object by control clicking on one of our points. And the function object reads up to that point until it receives a next message. And at that point, it triggers the release. And so the release portion, once again, sends a line message to ramp the volume down to nothing. So this essentially, when I click, I get sound, and when I release, I get the release. So there's no volume control essentially here. Okay, so here we're using the X dimension for the horizontal dimension for the frequency, and once again we're using a scale object, and it's giving us 3 octaves of range here from 110 to 880. And so those frequency values are being fed into this object. Now, SVF stands for state variable filter. This is a rather nifty little filter object, and it has 3 outputs. The first output gives us a low pass. The second outlet gives us a high pass. The third outlet gives us a band pass. And it has 4 outputs. The fourth is a notch filter, so that removes signal at the center frequency. This inlet controls the resonance value from 0 to 1, and the arguments here just set up the initial values. So the initial center frequency is 440, and the initial resonance is 0.5. And you can see we're using the Y outlet of our picked slider to control the resonance, scaling it from a range from 0 to 1. The noise source is a special noise generator called a pink noise generator. Pink noise is a random signal that has an equal amount of energy in each octave. And it has a nice sort of musical sound to it. And so we have subtractive synthesis using noise as our source. And we go from pitched noisy signal to a broadband noise. We can still get a bit of change in the color of the noise. But the envelope is the attack and the release are fixed. So there's a simple approach to a different kind of synthesis concept. Try building the patch. Once you've got it working, replace the noise generator with a sawtooth oscillator and experiment with the low pass and high pass outputs of the SVF state variable filter. Have fun.